Hi everyone, I am Ramesh, Assistant Professor, Department of Mathematics of Dr. SNS Rajalakshmi College of Arts and Science. Welcome to all of you for these sessions for a case study analysis. So today we have discussed about the case study on graphical solutions of given LPP. So here we have some of the constraints, some of the paragraphs are given. From the paragraph, we analyze the case and we come to the conclusions part. What are the optimum solutions? Before that, we discuss everything from our students. The case study is continued by our students from what are they given, what are the profit, and what are the maximum or minimum for the manufacturers attains. So we everything solve or discuss from these sessions. So I call anybody from what are the given problem solving.
The manufacturer company uses wood and labor to produce table and chair. The unit of profit of table is ₹6 and the unit of profit of chair is ₹8. There is 300 board feet of wood available and 110 hours of labor available. It takes 30 board feet and 5 hours to make a table, where 20 board feet and 10 hours to make a chair. The total availability of the wood is 300, where the total labor hours is 110.
Yes, says correct. The problem statement of this case study is the unit profit for table is ₹6 and profit for chair is ₹8. So there are 300 foot feet and 4 feet for wood and 110 hours labors available to make all these things, and it takes 34 feet and 5 hours labors or table and 24 feet and also 10 hours for make a chair. So the resources are two resources. One is wood, another is labor. The tables and chairs, these two are make it by wood is 30 and chair is 20. Similarly for 300 wood is available and the labor is 5 hours, and for chair is 10 hours. The total availability is 110 hours. So what is the problem again? So I ask anybody how you proceed this case. Is anybody? Yes?
To determine the optimum productivity of wooden tables and chairs for a furniture manufacturer. So to solve by graphical method, before formulate as LPP, x1 and x2.
Why x1 and x2?
So there are two decision variables there.
Okay.
So x1 and x2, 6x maximize z is equal to 6x1 and 8x2.
Yes, good.
So then subject to constraints are 30x1 plus 20x2 less than or equal to 300, and 55x1 plus 10x2 less than or equal to 110, and x1 and x2 less than or equal to 0. Thank you.
Yes. Yes, he said correct. The formulation of LPP for the given data is maximum method is 6x1 plus 8x2, because the two decision variable x1 and x2. x1 is for number of table and x2 is for number of chairs. So the unit cost for table is 6 and the unit cost for table is 8. Therefore, it is optimum. Therefore, our optimum is maximum method, because we need maximum profit. Therefore, maximum method is 6x1 plus 8x2. Subject to the constraints 30x1 plus 20x2 less than or equal to 300, 5x1 plus 10x2 less than or equal to 110. These data are available, therefore we make it as x1, x2 greater than or equal to 0. Okay, it is LPP. Already we discussed in the previous videos. Continuously we solve this LPP using by graphical method. So anybody how solve this? Yes, Gogol.
Sir, after formulating the LPP, we are going to solve the equations through graphical method. And for that, we should first remove the inequality constraints and turn it into an equations. For that, 30x1 plus 20x2 is equal to 300. We are replacing the inequality constraints with z equal to. And we are going to find the coordinates for that equation. The first coordinates would be by taking x1 as 0, and x2 would be 300 divided by 20, which is 15. And for the second coordinates, 110 divided by 5, which is 10. Sorry.
Yes, we make it is. The first x1 0, then we have what is x2 value, and if it is x2 0, what is x1 value. So from these two equations, we get the x1
we
x2 points.
x1 as 0 and calculate the equation, and for the second coordinates, substituting x2 as 0 and calculating the equation.
Yes, good.
Like that we find coordinates.
Correct. Stop. Yes, he is correct. So we find what is x1, x2 value for corner points. So from this first equations, we have the inequality. We convert this inequality as equality. So what is the value of x1 and x2? If x1 0, x2 become 50. That is 20 x2 is equal to 300. Therefore x2 is equal to 300 by 20. Therefore it is 15. If x2 is 0, 30 x1 is equal to 300. Therefore x1 is equal to 300 by 30. It becomes 10. So if x is 0, y value, that is x2 value 15. If x is 10, y value is 0, that is x2 value 0. Likewise, the second equation. If x1 0, 10 x2 is equal to 110, therefore x2 is equal to 11. And if x2 0, 5 x1 is equal to 110, therefore the x1 value is 22. So it is a corner points. So we put all the points in the graph and we draw the graph. What is the feasible solutions that we find later? Okay, is it? So or then we proceed how we put it all the points here. If x is 0, y is 15, right? So we have these points, x is 0, y is 15. It is x is 0, y is 15. So the y value here, it is 0, 15. And x is 10, y is 0. So this point is 10, 0. So what is next step? Yes. What is next step?
Well, the next step is connecting the two dots.
Connecting these two dots by a line. Yes. Connecting these two dots by a straight line. So we connect this. So what is next? We check the inequality. Is it? You check this inequality. If inequality is less than or equal to 300. Therefore, we have the region. Where is the region? Is outside or inside?
Well, it's inside.
Inside, because it is less than, therefore it is inside the region. Good, correct. And next we plot this point 0. X is 0, y is 11. Therefore this point is 0, 11. So it is 0, 11. And here it is x is 22 and y is 0. So this point is 22, 0. So as usual, we join these 2 points by a line. Okay, is correct. And so what is next step here? Suppose it is considered inequality less than. Yes.
So
the region.
The constraint is less than or equal to the feasible region lies towards the origin.
Again, it's towards the origin. Yes, it is towards the origin. So we indicate that one by below arrow line. Right. How we find the feasible solution? How we find the feasible solution? Here.
Well, the area where the two equations intersect and the area is covered is actually the feasible solution.
Okay.
For the first one would be 0, 0, the origin point.
Yes.
Which can be named as A, and the B one would be 0,
Yes, correct. So we fix all this, everything is on a graph. We cut this line, we get this region. We cut this second line, we have this region. So it is our solution region. Is it? All right. So these all are our solution region. It is our solution regions. We denote this region as origin O, and this point is A, and this point is B, and this point is C. We know what is O, A, C value, but we don't know what is B coordinate points. How we get B points?
Well, we can formulate the equations.
After formulated that, how you get this B points? In this B point is obtained intersecting of the two lines. Therefore, we solve the two lines. Is it?
Yes.
Is it correct? Okay.
Yes, it correct.
We solve these two lines, then we get B value.
Yes.
Right? Now we find the conclusion part. What is optimum value? So what is the maximum product or maximum table chairs produced by the company? So that we discuss now. So I call one student.
The values are applied in the maximum is at x1 6x1 plus 8x2. Then ZO the value 6, 6. The value is 6. ZA 10, 0 value is 60. ZB 4, 9 value is 96. ZC 0, 11 value is 88. We need a maximum value. Is ZB is maximum value is 96. So the x1 value is 4. The x2 value is 9.
Yes, good, correct. Among this all the value, which one is maximum? 96.
96.
Therefore, our maximum Z value is, optimum value is 96.
Then x1 is equal to 4. X2 value 9.
The X value is
9.
So if x1 is 4 and x2 is equal to 9, we get optimum value. So maximum 96 product produce. Or 96 value we are 96. So that's what this case will be. Thank you.